Alright, next problem. We have a right triangle here listed as well. We will need to label the right triangle. So we'll have A in the corner, B in the corner, C up top, and D down the bottom if the triangle was flipped around. So we'll try to keep it in that same pattern. These proportions depend on having every one of the triangles labeled as this label is set. So we're trying to solve for BC, which means that BC is the focus of the middle, so therefore I will use the theorem that has BC listed. So I will use AB over BC equals BC over BD, sorry, DB, excuse me, and then I will plug in the information and solve. AB, of course, is the addition of AD and DB, so therefore we'll have 7 over Y is equal to Y over 2. Cross multiply and solve. We have Y squared is equal to 14, and this shouldn't be an X, should be a Y. Y is equal to the square root of 14. So again, we focused in on the proportion that used BC because BC was the side we're trying to solve for. We'd also use the BC formula if it was the side that was given to us as well. Alright, next example. Similar type situation, we'll label A, B, C, D. We're now trying to solve for AC, so we'll use the proportion with AC in it, plug in the information that we know. We have AB, of course, is AD plus DB, so we have 23 over Y is equal to Y over 18. Y squared is equal to 414, which simplifies down when we square root it to 3, square root of 46. Alright, next problem here says find E to the nearest tenth. So we'll relabel our figure. We'll have A, B, C, and D. We're looking for side BC, so therefore we'll use a proportion with BC, and our proportion will be AB over BC is equal to BC over BD. Filling in the information that we know that AB is the addition of the entire bottom, so we will have 20 over BC, which is the side I'm trying to solve for, so that will be E, and that will be equal to BC, which is E, over BD, which is given to us as 16. We will cross multiply then, and we will have E squared is equal to 20 times 16, which is 320. We will square root both sides, and we'll be left with approximately E as approximately 17.9. Then if we round to the nearest tenth, so our solution then will be C, 17.9. Okay, next problem. Alright, we have indirect measurement. The story problem states that Miss Alspach is constructing a kite for her son. She has to arrange 2 support rods so that they are perpendicular. The shorter rod is 27 inches long. If she has to place the short rod 7.25 inches from one end of the long rod in order to form 2 right angles or 2 right triangles with the kite fabric, what is the length of the long rod? So if we take a look at the picture given to us, the information 27 inches long and 7.25 inches for the short rod. How long does the long rod need to be? If we take a look at just one of these triangles, we should be able to solve all the problem then. Let's do that. Alright, if we draw a diagram of one of the right triangles formed as we talked about, and we list the things that we know that WX then is 7.25 inches, and that the half the length of the kite is 13.5 inches for XY. Using our information, the book's going to tell us to do some theorems with the information given to us with the labels. I'm going to relabel this in terms that we know as A, B, C, D, and that really leaves us with AD and CD, which means that we should utilize, not necessarily that, but we should utilize the formula with CD in it. So we'll use the proportion AD over CD is equal to CD over dB. And dB is really the length that we want. This is the large rod that will add to the kite. So we fill in the information that we know. We have 7.25 over 13.5 equal to 13.5 over our variable, or the value we're trying to solve for, x. Cross multiplying here, we have 7.25x is equal to 13.5 squared, which is 182.25. Divide both sides by 7.25, and we're left with a value of x is approximately 25.1379. And that should be a decimal there, 25. So that is the length of the second larger rod that we should have for the kite. Alright, last question here. This airplane says that a jet airliner has a wingspan BD of 211 feet. The segment drawn from the front of the plane to the tail, AC, intersects BD at point E. If AE is 163 feet, what is the length of the aircraft to the nearest tenth of a foot? So we're trying to find the entire length of the aircraft if part of it is 163 feet. So what we're really trying to solve for is this back section right here, EC. If we know that from here to here is 163, if we find EC, we could just simply add those together. To help us out here with our triangles, we have a right triangle here. We know that this length is going to be half of 211, so therefore it'll be 105.5. And if we relabel this picture to fit our triangle mold, we'll put A will be in the right spot, B down here, C up top, and D down at the bottom. So what we're really going to use is a proportion that utilizes CD, and CD is the middle section, and that is AD over CD equals CD over BD. AD was given as 163, CD as 105.5, 105.5 on top, and our value that we're trying to solve for, x. Squaring, cross multiplying here, so we have 105 squared will give us 11,130.25, and that'll be equal to 163x. Divide 163 on both sides, and we're left with 68.2837 for x. Take our 68.2837 and add that with the 163 from the wing already, and we should be pretty close to 231.3 feet, which is answer B. So the length of the plane to the nearest foot should be 231.3 feet. Alright, that ends our lecture for today. Problems that we'll look at are from page 535, numbers 1 through 7, and 14 to 37. Thanks for watching.